In this video, we'll be diving into KATA, Cerb's simple yet expressive format for structured data. So why did we invent yet another data format when JSON and YAML are already widely adopted? We ruled JSON out immediately. It wasn't designed for human pros. And we really did try to use YAML in the early days of automations. It was a minefield for people who weren't programmers. Guessed data types, convoluted escaping rules, cryptic multi-line text blocks, fragile lists. Ugh. We spent more time teaching people to appease YAML than teaching them how to build automations. KATA was designed for two equally important audiences, AI agents powered by large language models and everyday humans. While KATA is heavily inspired by YAML, it avoids YAML's many pitfalls. It's a collection of keys and their values, with the structure defined by indentation. Let's look at the basics of KATA syntax. KATA uses indentation with spaces to show structure. The root is implicit, so you can have multiple top-level keys. You can separate sibling keys with blank lines for readability. Keys must be unique among siblings, but can repeat elsewhere. You can add a forward slash and name for unique identifiers. KATA is designed to be flexible and context-aware. The meaning of keys in a KATA document depends on the dialect, the specific feature or tool in Cerb that's using it. Each dialect defines its own set of valid keys in their expected structure. Keys can have text values, and you don't need to escape colons or special characters. One of the most powerful features of KATA is that any value can be dynamically generated using placeholders or scripting. Comments are similar to YAML, but only for lines starting with a hash sign. You don't have to escape that character when using it anywhere in a value. Add an @ sign and one or more annotations to a key to convert its value to a specific data type. Every annotation supports a value on multiple lines as long as they are indented to the same level. You can use the @text annotation when you just want multiple lines of text. Let's quickly run through the available key annotations. @base64 converts a key's value from base 64 encoded text into binary. This is useful for raw bytes and images. @bit converts a key's value into a binary 0 or 1. For 0, the value can be 0, null, blank, false, off, no, or n. Any other value will return 1. @bool is the same as @bit, but for a false or true boolean. This is useful when sending data to a remote API that enforces data types in its schema. @CSV converts a comma-separated value into an array. @date converts a human-readable date value into a Unix timestamp. The date can be relative, like +2 hours, or absolute, like January 1st, 2025, 8 p.m. @int parses the key's value as a whole number. @JSON parses text as a JSON encoded value. This is particularly useful when processing an API response from a placeholder. You can also use it to set data types like null or empty object. @KATA parses a value as a KATA encoded document. Beyond triggering inception, this is particularly useful for dynamically generating KATA with automation scripting. @key sets a value using a dictionary path. For text values, you could just use a placeholder, but for non-text values, this will also preserve their data type. @list converts a text list of one line per item into an array. @nowrap reads the key's indented value as a text block and removes new lines and line feeds. @raw returns a key's text without substituting placeholders. This is useful for returning templates to be used later, like for every row in a table. @ref lets you break up complex trees into reusable sections with references. Define a reference with an ampersand prefix at the top level. Then use @ref to copy it elsewhere. You can even reference child keys or chain references for more flexibility. @text reads the subsequent indented lines as a multiple line value. This continues until the indent returns to the key's level or higher. End the text block with one or more indented blank lines to preserve trailing line feeds. And finally, @trim removes leading and trailing whitespace from a key's value. And that's a quick tour of KATA and Cerb. It's a flexible, secure, and human-friendly way to model structured data. If you want to learn more, check out the official Cerb documentation linked below.
YAML, you ain't my language.